Hello, today we're going to review a little simplifying rational expressions and solving rational equations. Now, what we want to do first with any of these rational expressions that we need to simplify is factor whatever we can. So when we're simplifying, it could just be simplifying one expression, it could be multiplying two expressions, dividing two expressions, or more than two. But the first thing we want to do with all these is factor what we can. So in this case, with number 2, nothing we can factor out of 6 and 15 because they're individual terms as far as the factoring we're going to do in this step. But we take a look at this 5x minus 25. We always want to look for common factors first, because then that will help us even in some of the larger values. It will help us get smaller values, help us factor to where we can cross some things out by factoring. Then this denominator, this x squared minus 9x plus 20, we want to go ahead and factor like we know how to factor quadratic trinomials. So this 20 is positive, and that means both signs are going to be negative. So we are looking for our products of 20 that add up to 9, so we have 5 and 4. So from here, what we can do is look to see what we can factor out. So we have an x minus 5 in the numerator and denominator, and they are being multiplied, not added. That's the issue that people will have sometimes, is go through and see, oh, well, we have x minus 5 and factor that out with like an x or a 5 or something in the denominator. It only works when it's multiplication, because we're shifting that from, think about it as we're shifting things to the front or back of the equation using the commutative property of multiplication, and then something divided by itself is 1. 1's our multiplicative identity. That's why it disappears. We have to think about why. So then we have a common factor here. 5 and 15 we can factor out of 5. This becomes a 1, and then this becomes a 3. But then we can also factor out a 3 from 3 and 6. So our numerators just go. Okay, our numerator is just going to be 2. Our denominator is this x minus 4. And then that's how we would go through and simplify those. Let's do one more with multiplication and then take a look at what the ones with division look like. And remember, when we are simplifying or doing some multiplication, doing some division, we are not looking for a common denominator and multiplying both sides by it. The main reason why is because it's illegal. There's no two sides. There's no equal sign. So if we are manipulating anything using multiplication, we'd have to multiply it by, like, say, 6x divided by 6x, because that's a form of 1, but that's not what we're doing here. So here we want to factor everything. We can factor out a 9 from this numerator, a 3 from this numerator. We always want to look for our greatest common factor first, whether that's a constant or variable or some combination of such. Here we factor this trinomial. We've got x minus 4 times x plus 2. All right, now we are ready to factor some things out. So we have an x plus 2 that we can factor out. We have a rogue line here, an x minus 4 that we can finally factor out. So now what we can do is factor this 3 out, because 6 divided by 3 is 2. So this just simplifies to 9 divided by 2x. Let's take a look at one that involves division. It's on one of these pages here. Here we go. When we are dividing with fractions, we want to multiply our numerator because we could write this out as, fraction divided by a fraction and then anything written out. We take your numerator, or, if we're looking at it in terms from our integers and polynomials unit, our dividend, we take our dividend, multiply it by the reciprocal of the divisor. So we multiply your numerator by the reciprocal of the denominator. So let's factor everybody while we're doing this. So we have the x squared minus x minus 12 factors to x minus 4 times x plus 3. And then the 3x minus 9 stays in the denominator, and we can factor out a 3. Then we have to multiply by the reciprocal of this denominator. So the reciprocal, we take our old numerator, becomes our new denominator, and our old denominator becomes our new numerator. And we can factor that x squared plus x minus 20 to x plus 5 times x minus 4. Oh no. All right, we are off the page. But that's an x minus 4. So then we go to everyone's favorite part of these problems. Well, not everyone. Some people love the factoring. We can just go through and factor out our x plus 3s, factor out our x minus 4s, factor out our x plus 5s. And we are left with a 3 in the denominator and nothing in the numerator. When there's nothing here, because we factored everything out, it's going to be 1. Because x minus 4 divided by x minus 4 is 1. X plus 5 divided by x plus 5 is 1. So you can't just have nothing. It's not just 0. It doesn't just disappear. It's going to be 1. Let's take a look at some solving equations while we're here. Remember, the first thing we want to do when solving our equations is factor denominators. We don't really care about factoring numerators because nothing's going to really factor out yet in most of these problems. It'll be something towards the end of the problem where we will need that. So what I'd like you to do is, factor, like we've been doing, factor out a common factor of 5 here. And then we want to mark what x can't equal. We find that by setting all of our denominators equal to 0, because if our denominator is equal to 0, we're dividing by 0, and that's a problem. I do not recommend doing that. It is dangerous to you and the people around you. Like calculators might explode, black holes might open up. Just don't divide by 0. So that's why x cannot, under any circumstances, equal -2. If we did get something later on where our problem that we solved said, hey, x can be equal to -2, we want to look back at this and say, no, it can't, because it wouldn't hold up during the entire problem. So then we want to find our least common denominator. And let's look at all of the different pieces of this, where we have a 5 as a factor in denominators, so that needs to be a factor in your least common denominator. It's not going to be 25 because we do not need to count it twice. Then we have x plus 2, which we need, but we only need it once. We don't need it twice. That's a common mistake that people make. They'll do like 5 times x plus 2 times x plus 2, or 25 times x plus 2 squared, or something, but we only need it once. Think about it in terms of what can you multiply, like what is the lowest value we can multiply everything by to get all of our denominators to factor out. So then we multiply. Okay, we, transport back to where we were. We multiply both sides of this equation by your least common denominator. And what you should do here is not multiply this out. Right? So don't multiply the 18 and the 5, because we're just going to jump around the page again, because we're just going to factor it right back out. So let us just not multiply when we don't have to. So we have negative 6 times 5 times quantity x plus 2. Now, if you've done this correctly, you should have all of your denominators factor out. So from that term, we're left with an 18. From here, the 5s factor out. So we have to distribute the 4. Solve like you know how to solve from here, our linear or quadratic or more equations. So we have word not cooperating here. So we've got 4x plus 8. And then our x plus 2's will factor out here, so we have negative 30. This is going to be a linear problem, our first degree. So we will subtract 18 from both sides, subtract 8 from both sides. So we end up with 4x is equal to, negative 56. Divide both sides by 4, and we get x equal to, what is it? Negative 14. We double check. Negative 14 is not negative 2, so that is a valid solution. Same thing is going to happen down here. We are going to factor this denominator first, and we end up with x minus 6 times x plus 2, which is convenient because those are factors of our other denominators here. We want to set that x cannot be equal to 6 or negative 2, which we get by setting our denominators equal to 0 and solving for x, because we cannot divide by 0. Our least common denominator is going to be that x minus 6 times x plus 2. Because x minus 6 is represented here, and then x minus 2 is also in multiple locations, so we don't need to count it twice unless, say, one of your denominators was x minus 2 the quantity squared. In that case, your least common denominator would be x minus 6 times x plus 2, that quantity squared, because that is what is needed to get that denominator to completely factor out. So we multiply both sides by our least common denominator. So we have 2 times x minus 6 times x plus 2 divided by x minus 6. I like writing this whole step out just to make sure that you do not miss anything. And I know it's a bunch of writing, but you do have that satisfaction of all of the factoring out that happens afterwards. I'm writing this one out as the x squared minus 4x minus 12 because we know that the whole denominator is going to factor out, so we're just going to leave it like that. So our x minus 6 is factor out, so we need to distribute that too. So we have 2x plus 4 plus our x minus 2's factor out. We need to distribute these 7 with what's left. So we have 7x minus 42. Then the whole denominators factor out. So we have 4x plus 2. All right. So here, let's get all of our x's onto one side. So we have 7x plus 2x is 9x. We have to subtract 4x from both sides. So we end up with 5x on the left. Then on the right, so we have 2, we need to subtract 4 and add 42. So we end up with 44 minus 4, which is 40. Divide both sides by 5, and we get x equal to 8, which we double check with up here. 8 is a valid value, so we are good to go. Thank you for watching. Let me know if you have any questions, and have a wonderful day.